Hello?
Can you hear me?
Yes.
Okay, right. So I can see that you are having difficulty trying to differentiate square root. Okay, right. So we look at this problem here. Y equals to x squared, then multiply with the square root of 1 minus 2x squared. So this consists of product of two functions, x squared and square root of 1 minus 2x squared. Okay, so the first one, you differentiate x squared, become 2x. And the second function, you just keep square root of 1 minus 2x squared. This one is correct. Oh, the second one, you keep the x squared, then you differentiate this one. Square root of 1 minus 2x squared. Square root of 1 minus 2x squared is actually, okay, it's actually 1 minus 2x square to the power of half. Square root means to the power half. Now, when you want to differentiate this function, you use the function of a function. So when you use function, the half you put in front. The half you put in front. Then 1 minus 2x square. Why like that? Okay, 1 minus 2x square. Now this half, you have to minus 1. When this half minus 1, it becomes negative 1 over 2. Okay? So you differentiate the power, right? Become 1 over 2. Bring down 1 over 2 and become negative 2. Then when you differentiate, what is inside the bracket one more time? Negative 4x. Okay, so this is how you get this. Is this okay?
Yes.
Okay, right. Now the differentiation part is over. This is dy dx. So you will get the marks for differentiation. But the simplification, the simplification. So I'll try to show you how to simplify. This one, you just copy down, right? And this one is actually this thing divided by 1. So this first term, okay. Now the second term, you have to look at what is at the numerator. Now this x squared is at the top numerator. This one also at the numerator. So this multiply with this is actually negative 4x cubed, negative 4x cubed. Then the negative 4 and the 2 can cancel. That's why you have this negative 2x cubed. Is this okay? The
Mm.
numerator, the top. So I kumpul, gather all the terms at the numerator, multiply them together. Then the number 2 and 4 can cancel. So you have negative 3. The x become x cubed. Now this one, because of the negative power, the index is negative. They are actually at the denominator. So it's actually 1 minus 2x at the denominator, 1 minus 2x squared. The negative shows that they are at the denominator. Power of half is square root. So I have the 2 layers there.
Why why is negative?
Which one negative?
The 1 over 2. the power.
Because here, this one, 1 over 2, you minus 1, become negative 1 over 2. This one, over here. When you differentiate, you have the power less by 1. You have to subtract 1. Okay, so far, okay. So now I want to add this term with the second term here. So I change the loop to this one. This one, the denominator is 1. The negative 2, the negative I put in front. Positive, negative is actually negative. So you remember A over B plus C over D. This is your A, this is B, this is C, this is D. Okay. So when you add them up, it's actually A times D. A times D, B times C. Because it's minus lah. Minus B times C over B D. So I multiply these two, this one with this. I multiply the 1 with 2x cubed. Now, when I multiply this diagonal here, right, the A and the D, A and D, the square root multiply with the square root, square root is actually to the power half. Then the other square root is actually to the power half. When you multiply them together, it's actually power of 1. That's why we have power of 1 here. When you multiply these two, they become power of 1. Then the 2x is still the 2x there. When you multiply the other diagonal, 1 times x cubed, 1 times 2x cubed is 2x cubed. The denominator, 1 times the square root, is still 1 times the square root. So this step, is it okay so far?
Okay.
Cross multiply, then the denominator, you multiply the two denominators together. So if this is okay, then I try to multiply out. 2x times 1 is 2x. 2x times 2x squared become 4x cubed. 4x cubed minus 2x cubed is 6x cubed. Okay. This one okay or not? Here?
Okay.
Then I factorize the 2x. I take out 2x. Take out 2x become 1. Take out 2x become 3x squared. So this is the final answer. So a bit complicated. You make use of differentiation of the indices, which is a fraction, and also a lot of algebraic terms. You need to have a very good basic in indices. So when you multiply the terms, then you have to know what is this. That's why I explained to you here all this, how to differentiate and how to deal with these algebraic expressions. So far, okay or not?
Okay.
Then we clear all the drawing. Then I show you another question here, which is also a fraction that you don't know, right? You don't know this fraction. Right. So x to the power x to the power, square root of x is actually x to the power of half. It's your x to the power of half. Now, when you differentiate, you have minus 1. The half you bring to the front. So you have the half in front. Then x to the power of negative half. Negative half. So how to differentiate? The half you bring to the front. Then the half you minus 1. So this is half at the front. Half minus 1 is negative 1 over 2. So when you differentiate the term at the top here, you will get this one. Then the term at the bottom, at the denominator, you just copy down. Just copy down. Okay. Then the second part, you have to minus. Now this one, you don't differentiate already. You leave it as square root of x. When you differentiate x plus 1, you have 1. Differentiate this, you get 1. Then divide by the denominator, you have square, denominator square. So far, this first step, the differentiation, can do or not? Can understand?
Can.
Can, okay. Now, it comes to the simplification. Again, you need to know how to handle algebraic expressions. Okay, so I treat this as at the top there. X plus 1 is at the top. This power negative is at the bottom. Half is square root. Then this number 2 is also at the bottom. Now, this is not a fraction. I change it to a fraction by dividing by 1. Now, why divide by 1? Because I want to apply the ABCD. Remember the ABCD? A over B plus C over D. So I make sure that this is all, how to say? This all A, B, C, D, so that I can cross them. Cross them. So x plus 1 multiply with 1 is x plus 1. Right? Multiply is the same. Then this one, square root of x, multiply with square root of x. Square root of x multiplied with square root of x is x. 2 is still there. So it become x plus 1 minus 2x. At the bottom there, these two multiply together. 2 square root of x will multiply by 1 is 2 square root of x. Then the denominator is x plus 1 squared. Maybe I should separate it afterwards, so that you can see clearly. So the denominator is x plus 1 squared. Now this, you remember I told you that one, A over B, then the long line is C. This is A over B multiply with 1 over C. So this is A over BC. This is the case. Now if it's like that, A over B over C is actually A multiplied with C over B. It's actually AC over B. So this one, there are 3 layers there. This is the top 2 layer. Then this one is the bottom layer. Let me separate them out so that you can see clearly, right? Separate them out so that you can see clearly. Yes. So see, then this one, this is another one. Then this one, another one. Like that is here. So like that is clearer. It's now all mixed up. Okay. So this one is a different level. This is the top, then this is the long line, and this is the bottom. This is the top, this is the long line, then this is the bottom. So you encounter this type of thing, and this one you leave it at the top, this one at the bottom, then you multiply with 1 over this. That's why this one goes to the bottom. Okay, so far can follow?
Can.
Can. Okay. So then where is it? Here, right here. Then so you do this one. Okay. This one, this one I've done for you. Which one I didn't do? Let's see. Okay. This is number 1. Is it number 1? This is number 1. Okay. So you do correction for this one. You just do correction for this one. I've sent you already this one. You do this one correction, no? 1b, 1b. Then another one with square root 1. This one I've shown you. This one. Not this one. Not this. I think, is it this one? Yeah, this one. You do correction for this. So 2 corrections. Right? This one. Then another one is this one. This one. Okay. So these 2 questions you do correction. That's all. Okay. I delete all these 2. You refer to your WhatsApp, right? Delete off this. Where are we now? Okay. So the correction done already. There is one more type of differentiation in your syllabus. That type of differentiation is called this implicit differentiation. It's called implicit differentiation. What is implicit differentiation? Don't be scared. So I'm going to explain to you using the chain rule. Now, so far you have been using the chain rule, but I didn't tell you the name is chain rule. Okay? Then what is chain rule? Okay, what is chain rule? Now, this chain rule is the rule we use when we do composite function. When you differentiate a composite function like this, like this, with the square root 1, you differentiate the power, then you differentiate one more time the inside, negative 4x. So actually what we are doing here, we're actually differentiating a function of a function or a composite function using the chain rule. But I didn't tell you this is chain rule because I don't want to confuse you with so many things, right? But now I have to explain to you because of this, this one, because of this. So I want to tell you the chain rule now. Okay, what is chain rule? Chain rule is this one. So it involves three variables, or at least two variables. You know what is a variable or not?
Yes.
Variable is x lah, y lah, z lah. Sometimes we even use t to represent the variables. Okay. So now we have three variables, x, y, and z. Okay. We have three variables, right? X, y, and z. Now you see, we have three variables, and I say, oh, please differentiate. It is meaningless to say differentiate because there are so many variables. You want to differentiate with respect to x, or you want to differentiate with respect to y, or you want to differentiate with respect to z. You have to tell me because there are so many variables, right? Earlier on, when we do this type of question, everything is x, or maybe there's one y here. Everything is in terms of x. So when you differentiate with respect to x. But that is not always the case. That is not always the case, right? So when we have three variables, x, y, and z, you can either differentiate with respect to x, you can differentiate with respect to y, or you differentiate with respect to z. Well, each of these will give you different answers. Whether you differentiate x, y, or z, the answers are all different. We're going to look at what is a chain rule. This chain rule will enable us to differentiate other variables, right? That does not exist that you cannot see, does not exist, that you didn't see in the question. Okay, right. Now the chain rule is like this. dz over dx, you remember the position of the variables, the position of the variables. dz dx equals to dz dy multiplied by dy over dx. This is the chain rule. Now, how to recognize the position of these variables? This is z, this is x, this is z, this is x. The position is like that. Then at the bottom here, this is y. At the top here, it is y. So can you see the arrangement in the composite function? We call the chain rule. The chain rule means the runtime chain rule. How are these variables chained together? How you chain them together? So you chain them together using the y. This is z and x. The z is here, the x is here. And you chain them together using the y, one at the bottom, one at the top here. Can you remember the chain rule? Yes. Okay, now I ask you. Now I want wait, I clear everything first. Now I want the dz over dt, dz over dt. T is another variable. So I start here, dz, then multiply. At the bottom here is dt. What to put in between here and here? Anything. Let's say you want to put x, you put x. here, then you put x here. You want to put y, then you put y here. Then here must be 1. The one, the center that chain them up must be the same. So do you know how to write down the chain rule?
Yes.
Yes. But the pattern the variables, they are arranged like that. But different question, I may give you different variables. Okay or not? Different questions, different variables. Okay, right. So now, okay, sabar. Okay, I clear this first. So now I have an equation here. dz, z equals to 3y squared. Z equals to 3y squared. The variable in this question is in that equation, right? Not question. In that equation is ada dua variable. Z and y, the two variables there, z and y. So now the question asks you to find what? Find dz over dx. Now dz over dx, if you see the x at the bottom there, if you see whatever is at the bottom there, that means they ask you to differentiate with respect to this one at the bottom there. Differentiate with respect to x. Then you may ask me, hey, there is no x in the equation. How can I differentiate with respect to x? That's when our chain rule comes in. Although the equation has no x, but I can still differentiate with respect to x. Okay, right. So I explained to you how to differentiate. You want to find dz over dx, right? So you write down dz over dx. Using the chain rule, this will be z, this will be x. Because I want to find dz dx now. And dx means what? Differentiate with respect to x. Okay. So I write down dz dx. What to fill in at the center here? What to fill in here and here? Then I look at the equation. There is one variable left. After writing z and x, there's one more that I didn't touch. That is the y. So I put here dy and dy. So do you know how to create the chain rule? Okay, right. So this is how I'm going to create the chain rule. And the first part is dz over dy. dz over dy, what is the meaning? It means that differentiate z with respect to y. Differentiate z with respect to y. So this is z. I differentiate with respect to y. Now, can differentiate or not? Differentiate with respect to y. So I bring down the power, becomes 6. Then the power less by 1 becomes 6y. So this thing, it becomes 6y, right? Then the next part, dy dx. I do not know what is the relationship between y and x. I don't know their relationship. So I just leave it as dy over dx. And this is the answer. Okay or not? If okay, then I repeat so that you can remember the process. You remember the process. I tell you the shortcut, right? Now this equation involving z and y. But I want you to differentiate with respect to x. So what you need to do is just differentiate this with respect to y. Then you put the dy dx at the behind that. Differentiate with respect to y. This one, differentiate with respect to y. Okay. How to create the new color? Cannot create a new color. Okay. Okay, never mind. So first of all, you differentiate with respect to y here. This one, differentiate with respect to y. Then you put down dy dx behind. That's how you differentiate, right? One more time, how to differentiate this with respect to x? You see, this y is not x, but yet I want to differentiate this y with respect to x. So how? You just differentiate as usual. Pretend that pretend that you are differentiating with respect to y, but in the end, you add one more term there, dy dx. That's all. Okay?
Mm.
Dy dx there. So this is how we differentiate and this type of equation. Okay, right. Now I have different written down one, two, three functions here, right? The three functions, they are this one, y square minus y, 2x plus 5, and square root of 3t plus 2. The first function involves y only. Second function involves x only. Third function involves t only. Okay? So now these three functions, I want to differentiate the following function with respect to y. I want to differentiate them with respect to y. Now, if this is y, right, this y, I want to differentiate with respect to y. Now, differentiate with respect to y means d dy. If the bottom is dy, means differentiate with respect to y. So what is d dy of this thing? I differentiate with respect to y with respect to y, right? So it's 2y, differentiate become 2y, differentiate y becomes 1. Is this okay?
Mm.
Okay, right. Now, the same thing. This is a function involving x, but I want to differentiate with respect to y. I want to differentiate. So, pretend that you are differentiating with respect to x. So you differentiate 2x plus 5 with respect to y. Differentiate 2x, 2. Differentiate 5, 0. But you are differentiating x with respect to y. So you put behind here dx, dy. So you put dy here. You are differentiating with respect to y. Now, what you are differentiating? You are differentiating x with respect to y. So you differentiate as usual. Then the behind one, you put the dy there. Whatever that you differentiate, x, then you put dy there. Because this function is the x function, so you put the x dy. This one, you just differentiate as normal. Why should I put a dy dx at the bottom? Behind there? Because of this. Because of the chain rule. You see, when you differentiate as usual, differentiate this as usual, but you put behind there dy dx, right? So the same thing here, you differentiate as usual, right? This one you differentiate as usual, but behind there you put dx dy. Why this one no need to put dx dy there? This one, because you are differentiating y with respect to y. You differentiate y with respect to y, you don't have to add something behind. But you differentiating x with respect to y, then you put dx dy behind there. Is this okay? You just remember it as if it is a rule lah, as if it's a rule. When you differentiate a variable that is not the variable that you with respect to, then you just add another dx dy at the behind there. Okay or not?
Okay.
Okay. Now I want to differentiate this function t, but I want to differentiate with respect to y. So I put there d dy of this thing. What is the meaning of d dy? D dy means differentiate with respect to y. Differentiate with respect to y. So this d, I want to differentiate with respect to y. You differentiate like normal. This is to the power of half. Bring down the half. Then the half minus 1 become minus half. Then differentiate what is inside the bracket. 3. Complete. The differentiation is complete. Right? Half 3t plus 2 negative half. Differentiate inside 3. However, you are differentiating t with respect to y. You are not differentiating t with respect to t. So if you're differentiating t with respect to t, then you don't have to add something there. However, you are differentiating t with respect to y. So you add another term here, dt over dy. Where the t come from? The t come from the function. Where the dy come from? The dy come from differentiating with respect to y. Now this one you simplify, then you get this. So far, slowly, you think over all these things, the 3 examples, you compare them, then you think about it. Any question you want to ask me. Slowly, no need to go fast. So far, okay or not? Okay, so I summarize.
Just differentiate by just now that few questions like that, but just plus the dy and dx behind.
Correct. You differentiate y with respect to y, no need to put anything behind. Because this is y, you differentiate with respect to y, no need to put anything behind. You differentiate x, but with respect to y, then you put dy dx behind. You differentiate t with respect to y, then you put dt dy behind. Okay or not? Okay. So now we look at the same question. Now I want to differentiate the following function with respect to x. So you remember, you want to differentiate with respect to x. Now this is y. You want to differentiate with respect to x, you put dy dx behind. This is x. You differentiate with respect to x. No need to put anything behind. This is t. You want to differentiate with respect to x. You put dt dx behind. Okay, no? So it depends on the variable. What variable you want to differentiate. If it's the same variable, no need to add anything. If it's a different variable, then you put that variable with respect to what you want to differentiate. Okay or not?
Okay.
Okay. Now this one the same. I want to differentiate with respect to t. Oh, this is y. I want to differentiate with respect to t. So I put dy dt there. Oh, this is x. I want to differentiate with respect to t. So I put dx dt there. Oh, this is t.